Hello everyone, this is Steve. Thanks for joining me. So if we're trying to solve for x in a logarithmic equation, as long as we have a single logarithm on each side, and those logarithms have the same base, we can just remove the logarithms and solve for x from there. Of course, we'll still have to check our answer at the end. In these problems, you will notice that we do not have a single logarithm on each side. I've got another two down here, which we're going to do in a bit here. So we need to condense and then remove the logarithms. Let's get started. See this minus sign right here? We're going to combine the two logarithms on the left-hand side using the quotient rule. So it's going to be ln of 5 plus 4x over 3 plus x equals ln of 3. Both sides have a single logarithm of base e. Remove the logarithms. 5 plus 4x over 3 plus x equals 3. Multiply both sides by 3 plus x to get rid of the fraction. So that's going to be 5 plus 4x equals 3 times 3 plus x. Distribute over there. 9 plus 3x. I'm going to subtract 3x from both sides and subtract 5 from both sides. You subtract 3x from both sides, this side will just be an x. If you subtract 5 from both sides, this side will just be a 4. The answer is 4 because if we take 4 and plug it back into the original equation, anywhere we see an x, we will only take the logarithms of positive numbers. So that one's cool. Let's do the next one. We have two logarithms on the left side, so we cannot remove the logarithms until we combine them into one logarithm. This will be done using the product rule. So this is going to be log x times x minus 21 equals log of 100. Since there's a single logarithm on each side and they are both base 10, we can just remove the logarithms. X times x minus 21 equals 100. So this is going to be x squared minus 21x, and then we subtract 100 from both sides. Get 0 over there, and then we try to factor this thing here. So, I don't know, what do we got? X, we've got a plus and a minus. Oh, you know what? It's going to be plus 4 and minus 25. That should do it. So our two answers at this point are going to be x equals negative 4 and x equals 25. However, the negative 4 is no good because when we try to plug it back in here for x, we end up taking the logarithms of negative numbers. 25 is fine because when we plug that in for x, we only take the logarithms of positive numbers. So we reject the negative 4 and we keep the 25 as our only answer. Okay, moving on to the other two on here. We're going to combine these two logarithms on the left into a single logarithm. We can do that because they're both base 2. This is going to be a quotient rule situation. And then what we can actually do is, before we even strip away the logarithms, I can recognize that x squared minus 9 is the same as x plus 3 times x minus 3. So if we've got that over an x minus 3, then the x minus 3's cancel, and this left-hand side is actually just log base 2 of x plus 3 equals log base 2 of 5 over here. Both sides are a single logarithm. They are both base 2. So we rewrite this as x plus 3 equals 5. Subtract 3 from both sides, and we get x equals 2. Now you will notice that if we try to plug 2 into our original equation, then we do end up taking the logarithm of a negative number here. We also end up doing it here. So 2, which was our only possible answer, doesn't actually work. So we reject that, and we say there is no solution to this problem right here. Okay, last one down here. This time we'll combine the two logarithms on the right-hand side. So we're going to have log base 0.5 of x plus 25 equals log base 0.5 of x plus 10 times 4. Remove the logarithms because there's a single one on both sides and they both have the same base. Get x plus 25 equals, let's distribute that 4x plus 40. Okay, subtract x from both sides. That will give me a 3x over here. Subtract 40 from both sides. That will give me a negative 15 over here. Divide both sides by 3, and I'll get x equals negative 5. I don't like the looks of that negative answer, but it turns out it's fine, because if you plug negative 5 in here or in here, you're still taking the logarithms of only positives. So this answer is just fine. Okay, I hope that helped. Thanks for watching.